Time moves like a tide rolling quietly to shore. Tonight we're going somewhere dark. Not frightening, but hushed, ancient. A world that begins just below the waves and stretches into the deepest places on Earth. Places more mysterious than the surface of the moon. Tonight we're diving into the deep sea, or rather wondering why, after all, our progress, so much of it, remains untouched. It's strange, isn't it? We launch telescopes into the cosmos, land rovers on distant planets, map the galaxies, but when it comes to the ocean just beyond our toes, most of it is still a secret. Vast, uncharted, and almost dreamlike in its remoteness. So I wonder, where are you listening from tonight? And how far are you from the nearest coastline? A few miles? 1,000? Funny, isn't it? The sea is everywhere, and yet the deep is nowhere we ever go. For a moment, you're standing at the edge of the ocean on a quiet evening. The waves lap gently at your feet, and you can see perhaps 50 feet into the clear water before it fades to blue, then to black. What you're looking at is essentially the edge of the known world, because beyond that point where the light fails, beyond that curtain of blue darkness, lies the largest living space on our planet. And we know almost nothing about it. The numbers are staggering when you really think about them. Our oceans cover more than 70% of Earth's surface. They contain 99% of the living space on our planet. And yet we have explored less than 5% of them. Less than 5%. We have better maps of Mars than we do of our own ocean floor. We know more about the surface of Venus, a planet shrouded in toxic clouds 400 degrees hot, than we do about the creatures living in the deepest trenches of our own world. But why? Why have we conquered the skies, split the atom, decoded the human genome, and yet the deep sea remains as mysterious today as it was to our ancestors who first gazed out at the endless horizon? The answer isn't simple, and it's not what you might expect. It's not just about technology, though that plays a part. It's not just about money, though that matters too. It's about something deeper, something that speaks to the very nature of exploration itself and the strange relationship we humans have with the unknown. You see, space exploration captures our imagination in ways that ocean exploration never quite has. When we look up at the stars, possibility, adventure, the final frontier. When we look down into the dark water, something else entirely, something that makes us uncomfortable in ways we don't quite understand. The ocean is alien, but it's alien in our own backyard. It's foreign, but it's also intimate. It covers most of our planet, influences our weather, provides our oxygen, and yet it might as well be on another world entirely. The deep sea begins where the sunlight ends. At about 200 meters down, roughly 600 feet, the last traces of sunlight fade away completely. Below this point, in what scientists call the aphotic zone, there is no light at all. None. It's a darkness more complete than anything you've ever experienced. Close your eyes right now and notice that even in the darkest room, you can sense some difference between your eyelids and the space beyond them. In the deep sea, there is no such distinction. The darkness is absolute, pressing, alive in its completeness. And in this darkness, life continues. Not just continues, but thrives. The deep sea is home to more species than anywhere else on Earth. Creatures so strange, so perfectly adapted to their alien environment that they seem like something from science fiction. Bioluminescent jellyfish that pulse with their own cold light. Fish with transparent heads and tubular eyes that rotate to track prey above them. Squid the size of school buses with eyes as large as dinner plates. Tube worms that grow in gardens around volcanic vents, feeding on chemicals that would be toxic to almost any other form of life. These creatures have evolved in isolation for millions of years, developing survival strategies that seem impossible. Some can withstand pressure that would crush a human body instantly. Others can survive in water so hot it would boil on the surface, or so cold it's barely liquid. Some create their own light through chemical reactions in their bodies. Others have evolved to be completely transparent, invisible ghosts drifting through the eternal night. But here's what's truly remarkable. We've only just begun to discover them. Every expedition to the deep sea brings back species that science has never seen before. Not just new varieties of known creatures, but entirely new forms of life. Animals that don't fit into our existing categories, that force us to rewrite our understanding of how life works on this planet. And the deeper we go, the stranger it gets. The deepest parts of our ocean are more than 11 kilometers down, more than 6 miles beneath the surface. The pressure there is more than 1,000 times greater than at sea level. The temperature hovers just above freezing. No sunlight has ever reached these depths. And yet, even there, life exists. Creatures that have never known warmth or light, that live in a world of eternal winter night, continue the ancient dance of survival that connects them to every other living thing on Earth. Think about that for a moment. While you're listening to this, perhaps settling in for sleep, perhaps watching the familiar patterns of light and shadow in your room, there are creatures living their entire lives in places where no human has ever been. Places where no human could survive for even a moment without technology. Places that are, in every meaningful sense, as alien as anything we might find on distant planets. And yet we know they're there. We catch glimpses of them, brief encounters through the tiny windows of deep-sea submersibles, or the lenses of remote cameras. We bring back specimens that astonish us with their strangeness. We map the contours of underwater mountains and valleys that dwarf anything on land. We discover ecosystems that operate on principles we're only beginning to understand. And with each discovery, we realize how much more there is to learn. The question that haunts every deep-sea researcher is not whether there are more discoveries to be made, but whether we'll ever make them all. The deep sea is vast beyond comprehension. It contains mountain ranges longer than the Himalayas, canyons deeper than the Grand Canyon, plains that stretch for thousands of miles without a single landmark. It contains rivers and waterfalls, forests and deserts, all hidden beneath miles of water in the eternal dark. So tonight, as we begin this journey together into the deep, we're not just exploring the ocean, we're exploring the limits of human knowledge itself. We're asking why some frontiers call to us while others remain forever beyond our reach. We're wondering what it means to live on a planet where the vast majority of living space remains unknown, unexplored, and perhaps unknowable. The story we're about to tell is not just about the deep sea, it's about mystery itself. About the strange fact that in an age when we can video call someone on the other side of the world, when we can sequence DNA and predict the weather and land spacecraft on asteroids, there are still places on our own planet that remain as mysterious as they were 1,000 years ago. Places where dragons might still live, if dragons were real. Places where the impossible is just another Tuesday. So let yourself drift now, like a particle of marine snow sinking slowly through the water column, past the familiar surface waters where dolphins play and fishing boats work, down through the twilight zone where the last traces of sunlight fade away and into the deep, into the place where our planet keeps its oldest secrets, where life writes its strangest stories, and where the future of exploration waits in the eternal dark. The deep sea is calling, not with words or sounds, because sound travels strangely in the deep, but with something older and more fundamental. The call of the unknown, the whisper of mystery, the promise that no matter how much we learn, there will always be more to discover, always deeper to go, always further into the dark. Chapter 1: The Invisible Ocean. An exploration of why the deep sea remains hidden from human experience, discussing the physical barriers that separate us from 99% of Earth's living space, the psychological distance we feel from underwater realms, and how the ocean's three-dimensional nature makes it fundamentally different from land-based exploration. The deep sea. It's a world so close and yet so utterly removed from our daily experience. We think of the ocean as a single, unified entity, but that shimmering surface hides a reality far more complex, far more alien than we can readily imagine. Consider this: 99% of Earth's living space is aquatic. 99%. Think of all the land, all the mountains and deserts and forests that occupy our minds and shape our lives. Now realize that all of that is just 1%. The vast majority of our planet, the stage for nearly all life, lies hidden beneath the waves. So why is it so invisible to us? What keeps us from truly grasping the scale and significance of this underwater realm? Part of the answer lies in the sheer physical barrier of water itself. We are land creatures, evolved to breathe air, to walk on solid ground, to see through the relatively clear medium of the atmosphere. Water, on the other hand, is dense, opaque, and often turbulent. It absorbs light, scatters sound, and resists our every attempt to move through it quickly and easily. Imagine trying to explore a vast, unknown continent while wearing a heavy, restrictive suit, unable to breathe the air or see clearly through the fog. That's a small taste of what it's like to explore the deep sea. But the physical challenges are only part of the story. There's also a psychological distance, a disconnect that runs far deeper than just the water's surface. Think about the last time you saw the ocean. Perhaps you were standing on a beach, gazing out at the horizon. What did you see? Most likely, you saw a flat, two-dimensional plane, a line separating the sky from the water. Even if you were on a boat surrounded by water on all sides, your perspective was still largely limited to the surface. You might have seen waves, perhaps a few seabirds, maybe even a glimpse of a whale breaching, but you were still only scratching the surface, quite literally. The ocean is fundamentally three-dimensional. It extends not just horizontally but vertically, plunging thousands of meters into the abyss. And it's in that vertical dimension where the true mystery lies. We are creatures of the surface, accustomed to navigating a world of flat plains and easily visible landmarks. We build roads and cities, we draw maps, we divide the land into neat, manageable parcels. But the ocean defies such categorization. It is fluid, dynamic, constantly shifting. There are no fixed points of reference, no easy ways to orient ourselves. Imagine trying to navigate a dense fog with no landmarks, no compass, and no sense of direction. That's the reality of exploring the deep sea. And that three-dimensionality creates a profound psychological barrier. We struggle to the sheer scale of the ocean's depths. We can intellectually grasp the numbers, the kilometers, the meters, the pressure, but it's difficult to truly internalize them, to feel them in our bones. It's like trying to imagine the vastness of space. We know that the universe is incomprehensibly large, but our minds can only grasp a tiny fraction of it. The deep sea presents a similar challenge. It's a world so vast, so alien, that it's almost impossible to comprehend. Consider this. If you were to drain all the water from the ocean, you would reveal a landscape more dramatic and varied than anything on land. There are mountains taller than Everest, canyons deeper than the Grand Canyon, and plains that stretch for thousands of kilometers. But all of this is hidden from view, obscured by the water above. Only the surface, the shimmering veil that conceals the true nature of the ocean. And because we can't see it, we don't fully appreciate it. We don't understand its importance, its fragility, or the vital role it plays in maintaining the health of our planet. We treat the ocean as a dumping ground, a source of endless resources, a place to be exploited and ignored. We pollute it with plastic, we overfish its stocks, we disrupt its delicate ecosystems. And we do all of this largely out of ignorance. Because we don't see the deep sea, we don't understand the consequences of our actions. Imagine if we treated the Amazon rainforest the same way. If we clear-cut its trees, polluted its rivers, and hunted its animals to extinction, all without ever seeing the forest itself. We would be horrified. But that's essentially what we're doing to the deep sea. We're destroying a world we don't even understand. A world that may hold the key to our planet's survival. The ocean's three-dimensional nature also affects the way we study it. On land, we can walk across vast distances, collecting samples, observing wildlife, and mapping the terrain. In the ocean, we are limited by the depth, the pressure, and the darkness. We rely on submersibles, remotely operated vehicles, and sonar to explore the deep sea. These technologies are powerful, but they are also expensive and limited. They can only explore a tiny fraction of the ocean, and they can only stay underwater for a limited amount of time. It's like trying to explore a vast forest with a single drone, flying high above the trees, taking only a few snapshots before returning to base. You might get a general sense of the forest's layout, but you would miss the details, the nuances, the hidden wonders. And that's the challenge of exploring the deep sea. We are trying to understand a world that is fundamentally different from our own, using tools that are inherently limited. But despite these challenges, we are making progress. With each new expedition, with each new discovery, we are slowly peeling back the layers of mystery that shroud the deep sea. We are learning about the incredible biodiversity that thrives in the dark depths, the bizarre creatures that have adapted to extreme conditions, and the vital role that the ocean plays in regulating our planet's climate. We are discovering new ecosystems, new species, and new insights into the nature of life itself. And as we learn more, we are beginning to realize just how much we don't know. The deep sea is a vast, unexplored frontier, a world of endless possibilities and untold secrets. It's a world that challenges our assumptions, that expands our understanding of what's possible, and that reminds us of the limits of our own knowledge. But what exactly are those limits? What are the physical and technological barriers that keep us from truly conquering the deep? What challenges must we overcome to explore this final frontier? Next, we'll delve into the crushing pressure, the absolute darkness, and the frigid temperatures that make the deep sea a truly hostile environment, even more so than outer space. Chapter 2: Pressure and Darkness. A deep dive into the extreme physical conditions that make deep-sea exploration so challenging, examining crushing pressures, absolute darkness, near-freezing temperatures, and how these conditions create an environment more hostile to human life than outer space. Imagine standing at the edge of an abyss, a place where the sun's warmth and light simply cease to exist. That's the reality of the deep sea, a realm defined by extremes that challenge our very understanding of what life can endure. But before we can marvel at the bizarre creatures and alien landscapes, we must first confront the physical gauntlet that makes this world so inaccessible. What awaits us in the crushing depths? The most immediate and unforgiving obstacle is pressure. At sea level, we experience 1 atmosphere of pressure, the weight of the air above us. For every 10 meters we descend into the ocean, the pressure increases by another atmosphere. Now, picture this. The deepest point in the ocean, the Mariana Trench, plunges nearly 11,000 meters. At that depth, the pressure is a staggering 1,000 atmospheres. To put that into perspective, it's like having the weight of 50 jumbo jets pressing down on every square inch of your body. Imagine the feeling. A human being, unprotected, would be instantly crushed. Our lungs would implode, our bones would shatter, and our bodies would be reduced to a pulpy mess. It's a truly terrifying prospect. But the deep sea isn't just about pressure. It's also about darkness. Sunlight, the lifeblood of our planet, can only penetrate so far into the ocean. As you descend, the vibrant blues and greens of the surface world gradually fade, replaced by an oppressive twilight. By the time you reach a depth of 1,000 meters, it's as dark as midnight, even on the brightest day. This is the bathypelagic zone, also known as the midnight zone. Here, the sun's rays are completely extinguished, leaving a world shrouded in perpetual darkness. It's a world where sight becomes almost useless, where creatures must rely on other senses to navigate and survive. But what senses could possibly be useful in such an environment? And then there's the temperature. The deep sea is a frigid environment, with temperatures hovering just above freezing. In some areas, like the Antarctic bottom water, temperatures can drop below 0 degrees Celsius thanks to the unique properties of salt water. This extreme cold slows down metabolic processes, making it difficult for organisms to grow and reproduce. It's a world where life moves at a glacial pace. These 3 factors, pressure, darkness, and cold, combine to create an environment that is profoundly hostile to human life. It's a place where our bodies are pushed to their absolute limits, where our senses are rendered useless, and where survival depends on specialized technology and unwavering courage. Is it any wonder that the deep sea remains one of the last great frontiers on our planet? But consider this: even in outer space, astronauts are protected by pressurized suits, advanced life support systems, and a constant stream of communication with ground control. In the deep sea, explorers face similar challenges, but with a crucial difference. The ocean is a corrosive and unforgiving environment that constantly threatens to breach our fragile technological defenses. What are these defenses? The submersibles that venture into the deep sea must be incredibly strong to withstand the immense pressure. They are typically constructed from thick titanium or steel hulls, capable of withstanding thousands of pounds per square inch. These hulls are carefully engineered to prevent any leaks or weaknesses, which could lead to catastrophic implosion. The slightest flaw can be fatal. Inside the submersible, the atmosphere is carefully controlled to maintain a comfortable pressure and oxygen level for the occupants. Life support systems scrub carbon dioxide, remove excess moisture, and filter out any harmful contaminants. The crew must also wear specialized clothing to protect them from the extreme cold, as the water surrounding the submersible can quickly draw heat away from their bodies. But even with these precautions, the risks are enormous. A sudden pressure surge, a malfunctioning life support system, or a simple navigational error could quickly turn a deep-sea expedition into a deadly disaster. The deep sea demands respect, and it punishes any carelessness or complacency. What makes it worth the risk? And it's not just the physical dangers that make deep-sea exploration so challenging. It's also the psychological toll. Imagine being confined to a small, cramped submersible for hours or even days at a time, surrounded by absolute darkness and crushing pressure. The isolation can be overwhelming, and the sense of vulnerability can be intense. How do explorers cope? Deep-sea explorers must be highly trained and mentally prepared for the challenges they will face. They undergo rigorous psychological evaluations to ensure they can handle the stress and isolation of the deep sea. They also practice meditation and mindfulness techniques to help them stay calm and focused in the face of adversity. But even the most seasoned explorers can feel the weight of the deep. But the psychological challenges extend beyond the explorers themselves. The support team on the surface also faces immense pressure. They are responsible for monitoring the submersible systems, providing navigational guidance, and coordinating any emergency response. The lives of the explorers depend on their expertise and vigilance. What if something goes wrong? The deep sea is a world of sensory deprivation. In the absence of light, sound becomes the primary means of communication. Submersibles are equipped with powerful sonar systems that can map the seafloor, detect underwater objects, and communicate with other vessels. But sonar is not a perfect technology. It can be affected by water temperature, salinity, and the presence of marine life. And then there's the problem of visibility. Even with powerful lights, visibility in the deep sea is limited to just a few meters. The water is often murky and filled with particulate matter, which scatters the light and reduces visibility. This makes it difficult to navigate and to observe the surrounding environment. How do you find your way? The darkness also affects the way we perceive time. Without the familiar cues of sunrise and sunset, time seems to stretch and distort. Hours can feel like days, and days can feel like weeks. This can be disorienting and can make it difficult to maintain a sense of perspective. How do you stay grounded? The deep sea is a world of silence. The surface world is filled with the sounds of waves, wind, and human activity. But in the deep sea, these sounds are muffled or absent altogether. The only sounds are the faint hum of the submersible's machinery and the occasional crackle of the sonar. This silence can be both peaceful and unnerving. What does it do to your mind? But perhaps the most unsettling aspect of the deep sea is the feeling of being completely alone. Even though you are surrounded by a team of experts on the surface, you are still isolated in a hostile environment, cut off from the rest of humanity. This sense of isolation can be profound and can lead to feelings of anxiety and fear. How do you overcome it? The deep sea is a constant reminder of our own mortality. It is a place where the forces of nature are on full display and where human beings are dwarfed by the immensity of the ocean. This can be a humbling experience, but it can also be terrifying. How do you face your fears? And yet, despite all these challenges, there are those who are drawn to the deep sea. They are driven by a thirst for knowledge, a desire to explore the unknown, and a fascination with the bizarre creatures that inhabit this alien world. What motivates them? They are scientists, engineers, and explorers who are willing to risk their lives to unravel the mysteries of the deep sea. They are the pioneers of a new frontier, pushing the boundaries of human knowledge and technology. They are the heroes of our time. But are they truly heroes? But what about the cost? Deep-sea exploration is an incredibly expensive undertaking. The construction and operation of submersibles require vast amounts of money, resources, and expertise. Is it worth it? A single deep-sea expedition can cost millions of dollars, and the funding for these expeditions is often limited. This means that scientists must compete for scarce resources, and many important research projects go unfunded. Is this the best use of our resources? Consider this. The budget for space exploration dwarfs the budget for ocean exploration. NASA's annual budget is several times larger than the budget for all oceanographic research combined. Why do we prioritize space over the ocean? Some argue that space exploration is more important because it can lead to new technologies, new resources, and new opportunities for human expansion. Others argue that ocean exploration is more important because it can help us understand and protect our own planet. What do you think? It's often said that we know more about the surface of Mars than we do about the bottom of our own ocean. We have sent rovers to explore distant planets, but we have barely scratched the surface of the deep sea. Is this a reflection of our priorities? But perhaps the problem is not just about money. Perhaps it's also about imagination. Space exploration captures the public imagination in a way that ocean exploration does not. People are fascinated by the idea of traveling to other planets and discovering new life forms, but they often overlook the wonders that lie beneath the waves. Why is this? The deep sea is often seen as a dark, dangerous, and forbidding place. It lacks the romantic appeal of space, with its distant stars and alien landscapes. But the deep sea is just as mysterious and just as full of surprises. It deserves our attention and our respect. But how do we change perceptions? Perhaps we need to do a better job of communicating the importance of deep sea exploration. We need to show people the incredible creatures that live in the deep sea, the unique ecosystems that thrive in the absence of sunlight, and the crucial role that the deep sea plays in regulating our planet's climate. How do we get the word out? We also need to make deep sea exploration more accessible to the public. We need to create more documentaries, more museum exhibits, and more educational programs that showcase the wonders of the deep sea. We need to inspire the next generation of ocean explorers. How do we inspire? The deep sea is a treasure trove of scientific knowledge waiting to be discovered. It holds the key to understanding the origins of life, the evolution of species, and the complex interactions that govern our planet's ecosystems. We cannot afford to ignore it. What are we waiting for? But beyond the scientific and economic arguments, there is also a moral imperative to explore the deep sea. We have a responsibility to understand and protect this fragile environment, which is threatened by pollution, overfishing, and climate change. We are stewards of this planet, and we must act accordingly. What is our responsibility? The deep sea is a reminder that there are still mysteries to be solved, frontiers to be explored, and wonders to be discovered. It is a testament to the power of nature and the resilience of life. It is a place that challenges our assumptions, expands our horizons, and inspires our imagination. Let's dive deeper. But what if, despite our best efforts, the deep sea remains largely unexplored? What if the challenges of pressure, darkness, and cold prove too difficult to overcome? What if we are destined to only ever glimpse the edges of this vast and mysterious realm? Would that be a failure? Perhaps not. Perhaps there is value in knowing that there are still places on our planet that remain beyond our reach. Perhaps there is value in preserving the mystery and the wonder of the deep sea. Perhaps there is value in humility. And as we begin to unlock the secrets of the deep, we find more than just strange creatures and bizarre landscapes. We find entire ecosystems that thrive in the absence of sunlight, fueled by chemical energy from hydrothermal vents. We discover new species at an astonishing rate, each one more bizarre and wondrous than the last. But what exactly these creatures, and how do they survive in such an alien environment? That's what we'll explore next. Chapter 3. The Technology Barrier. Investigating the engineering challenges of deep-sea exploration, from the limitations of current submersibles to the enormous costs of deep ocean research, comparing space exploration budgets to ocean exploration funding, and exploring why it's easier to send robots to Mars than to the bottom of it. The crushing pressure, the utter darkness, the near-freezing temperatures. These aren't just interesting challenges, they are the fundamental barriers to entry. To truly explore the deep sea, we need technology that can withstand, overcome, and even thrive in these hostile conditions. And that, as you might imagine, is easier said than done. Think about it. A submersible designed to reach the deepest parts of the ocean, like the Challenger deep in the Mariana Trench, needs to withstand pressures exceeding 1,000 times the atmospheric pressure at sea level. That's like having the weight of 50 jumbo jets pressing down on every square inch of its surface. materials science becomes paramount. The hull needs to be constructed from incredibly strong yet lightweight materials like titanium alloys. But even with the best materials, there are limits. The deeper you go, the thicker the hull needs to be, and the heavier the submersible becomes. This creates a vicious cycle. More weight requires more powerful propulsion, which requires more energy, which adds even more weight. It's a delicate balancing act, pushing the boundaries of engineering with every meter of depth. And it's not just the pressure. The cold is relentless. Near-freezing temperatures can wreak havoc on electronics, batteries, and hydraulic systems. Special insulation and heating systems are required to keep everything functioning. But these systems, of course, add weight and complexity. Then there's the darkness. Imagine trying to navigate through a dense forest at midnight without a flashlight. That's the reality in the deep sea. We need powerful lights to illuminate the surroundings and sophisticated sonar systems to map the terrain. But even with the best technology, visibility is often limited to just a few meters. The submersibles themselves are marvels of engineering, but they're only one piece of the puzzle. Getting them to the deep sea in the first place requires specialized support ships, equipped with powerful cranes and winches. These ships are essentially floating laboratories, housing teams of scientists, engineers, and technicians. But here's the kicker. All of this comes at an enormous cost. A single deep-sea submersible can cost tens, even hundreds of millions of dollars to design, build, and operate. The support ships, the research teams, the ongoing maintenance, the expenses quickly add up. And this is where a crucial comparison comes into play: space exploration. Consider the budget for NASA, the agency responsible for exploring the vast expanse of space. In 2023, NASA's budget was over $25 billion. That's a staggering sum dedicated to unraveling the mysteries of the cosmos. Now, compare that to the funding for ocean exploration. The National Oceanic and Atmospheric Administration, or NOAA, is the primary federal agency responsible for ocean exploration in the United States. While NOAA's overall budget is significant, the portion dedicated specifically to deep-sea exploration is a tiny fraction of NASA's. We're talking about a difference of orders of magnitude. Why is there such a disparity? Why are we spending so much more money to explore space than we are to explore our own ocean? Part of the answer lies in public perception. Space exploration captures the imagination in a way that ocean exploration often doesn't. Images of distant galaxies, astronauts walking on the moon, and rovers exploring Mars are iconic and inspiring. They fuel our sense of wonder and our desire to push the boundaries of human achievement. The deep sea, on the other hand, is often perceived as a dark, forbidding, and somewhat frightening place. It's a world of crushing pressure, bizarre creatures, and seemingly endless darkness. It doesn't have the same romantic appeal as the stars. But perhaps there's something more fundamental at play. Maybe it's about accessibility. We can look up at the night sky and see the stars with our own eyes. We can follow the progress of space missions through stunning images and videos. Space, in a sense, feels closer to us. The deep sea, on the other hand, is hidden from view. It's a world that requires specialized equipment and expertise to access. It feels remote and inaccessible, even though it's right here on our own planet. And this brings us to a rather uncomfortable truth. It's often easier to send a robot to Mars than to send one to the bottom of our own ocean. Think about the challenges involved. A Mars rover needs to withstand extreme temperatures, radiation, and the vacuum of space. It needs to travel millions of miles, navigate autonomously, and collect data in a remote and hostile environment. But a deep-sea robot faces a different set of challenges. It needs to withstand crushing pressure, navigate in complete darkness, and operate in a corrosive saltwater environment. It needs to transmit data through miles of water, often with limited bandwidth. And it needs to do all of this while being tethered to a surface ship by a fragile cable. The engineering challenges are immense, but the funding is often lacking. As a result, deep-sea exploration has lagged behind space exploration in many ways. We have better maps of Mars than we do of the ocean floor. We know more about the composition of distant asteroids than we do about the biodiversity of deep-sea ecosystems. This isn't to say that deep-sea exploration is neglected entirely. There are dedicated scientists, engineers, and institutions working tirelessly to unlock the secrets of the deep. They are developing new technologies, pushing the boundaries of what's possible, and making incredible discoveries. But the pace of exploration is slow, and the resources are limited. We are only scratching the surface of what the deep sea has to offer. Consider the limitations of current submersibles. While they are marvels of engineering, they are still relatively slow and cumbersome. They can only stay underwater for a limited amount of time, and they require extensive support from surface ships. Remotely operated vehicles, or ROVs, offer a more flexible alternative. These underwater robots are tethered to a surface ship by a cable, allowing them to explore the deep sea for extended periods of time. But ROVs are still limited by the length of their cables, and they can be difficult to maneuver in strong currents. Autonomous underwater vehicles, or AUVs, are the next frontier in deep-sea exploration. These robots can operate independently without being tethered to a surface ship. They can be programmed to follow predetermined routes, collect data, and even make decisions on their own. But AUVs are still in their early stages of development. They are expensive, complex, and require sophisticated software and sensors. They also face challenges in terms of navigation, communication, and power management. Despite these challenges, the potential rewards of deep-sea exploration are immense. The deep sea is home to a vast array of undiscovered species, unique ecosystems, and valuable resources. It plays a crucial role in regulating the Earth's climate, and it holds clues to the origins of life itself. So, how do we overcome the technology barrier? How do we unlock the secrets of the deep sea? The answer, of course, is it requires increased funding, technological innovation, and a greater public awareness of the importance of ocean exploration. We need to invest in the development of new submersibles, ROVs, and AUVs. We need to improve our sensors, communication systems, and power sources. We need to train a new generation of deep-sea explorers, scientists, and engineers. But perhaps most importantly, we need to change the way we think about the deep sea. We need to recognize its importance, appreciate its beauty, and understand its fragility. We need to see it not as a dark and forbidding place, but as a vital part of our planet, a treasure trove of knowledge, and a source of endless wonder. And it is with a sense of wonder that we begin to see past the technological challenges, past the limitations of what we believe is possible, and begin to see the vast potential for life itself. As we discover in the next chapter, the abyss is not a barren wasteland, but a teeming metropolis of the strange and wonderful. What you are about to discover will change everything you thought you knew about life on Earth. Before we dive deeper into this incredible journey, I'm curious, where in the world are you watching this from? Drop a comment below and let our global community know. And if you're finding this as mind-blowing as I am, hit that like button to help more people discover this story. Chapter 4: Life in the Abyss. Discovering the incredible biodiversity of the deep sea, exploring bioluminescent creatures, extreme adaptations, chemosynthetic ecosystems around hydrothermal vents, and the constant discovery of new species that challenge our understanding of life itself. Imagine a world teeming with life, yet bathed in perpetual darkness. A realm where the rules of survival are rewritten, and the bizarre becomes commonplace. Forget sunlit coral reefs and playful dolphins. We're diving into the abyss, where life finds a way, even under unimaginable pressure. The deep sea isn't just a barren wasteland. It's a vibrant, pulsating ecosystem, a testament to the resilience and adaptability of life itself. And what you're about to hear might just change everything you thought you knew about our planet. How can anything survive down there? The crushing pressure alone, it's enough to turn a submarine into scrap metal. Yet, life flourishes. It thrives in ways that defy our understanding of biology. Let's start with the masters of disguise, the creatures that paint the darkness with their own light, the bioluminescent beings. Imagine a living constellation, drifting through the inky black. Each flash, each pulse, a carefully crafted signal in a world without sunlight. These aren't just random flickers. Bioluminescence is a language, a tool for survival. Some use it to lure unsuspecting prey, dangling shimmering lights like irresistible bait. The anglerfish, with its bioluminescent lure, is a classic example, a patient predator in the eternal night. Others use it for defense, unleashing blinding flashes to startle predators, giving them a precious moment to escape. Think of it as a living flashbang grenade. And still others use it for communication, sending signals to potential mates, creating dazzling underwater courtship displays. It's a romantic ballet performed in the dark, but bioluminescence is just the tip of the iceberg. The adaptations required to survive in the deep sea are truly mind-boggling. Consider the pressure. At the bottom of the Mariana Trench, the deepest point in the ocean, the pressure is over 1,000 sound times greater than at the surface. That's like having the weight of 50 jumbo jets pressing down on you. So how do deep-sea creatures survive? They've evolved unique physiological adaptations. Many lack swim bladders, the gas-filled organs that help fish control their buoyancy, which would simply implode under such pressure. Their bodies are often soft and gelatinous, allowing them to withstand the immense pressure without being crushed. Think of them as living water balloons, perfectly adapted to their environment. And their metabolism is incredibly slow, conserving energy in a world where food is scarce. They live life in slow motion, patiently waiting for their next meal. But perhaps the most astonishing adaptation is the ability to thrive in the absence of sunlight. Sunlight, the engine of life on Earth, only penetrates the first few hundred meters of the ocean. Below that, it's perpetual darkness. So, how do organisms survive without photosynthesis? The answer lies in chemosynthesis, a process that allows organisms to create energy from chemicals rather than sunlight. And the epicenter of chemosynthetic life? Hydrothermal vents. Imagine underwater volcanoes spewing out superheated water and chemicals from the Earth's interior. These aren't barren wastelands. They're oases of life, teeming with unique and bizarre creatures. Tube worms, giant clams, and blind shrimp huddle around these vents, forming thriving ecosystems in the middle of the dark abyss. These creatures rely on bacteria that convert chemicals like hydrogen sulfide into energy, forming the base of the food chain. It's a completely independent ecosystem, powered not by the sun, but by the Earth itself. These hydrothermal vent ecosystems are not only fascinating, they're also incredibly important. They provide insights into the origins of life on Earth and the possibility of life on other planets. And here's the truly mind-blowing part. We're still discovering new species in the deep sea at an astonishing rate. Every expedition, every submersible dive reveals creatures that have never been seen before. Fish with transparent heads, jellyfish that look like alien spaceships, and worms that glow with an otherworldly light. It's like exploring a new planet right here on Earth. Just a few years ago, scientists discovered a new species of anglerfish in the Gulf of Mexico. It was unlike anything they had ever seen before, with a bioluminescent lure that resembled a tiny disco ball. And in 2020, a team of researchers discovered a new species of jellyfish in the Mariana Trench. It was a ghostly white creature with long, flowing tentacles, a true denizen of the deep. These discoveries are not just adding to our knowledge of biodiversity, they're challenging our understanding of life itself. They're forcing us to rethink what's possible and to appreciate the incredible adaptability of life on Earth. But what about the sheer scale of the unknown? How much of the deep sea remains unexplored? The answer, as you might suspect, is almost all of it. We've explored less than 5% of the ocean floor. That means that 95% of the deep sea remains a mystery, a vast, unexplored wilderness teeming with untold secrets. Think about that for a moment. We know more about the surface of Mars than we do about the bottom of our own ocean. Unmapped mountain ranges, unexplored trenches, and undiscovered ecosystems, they're all waiting to be found. Every deep-sea expedition is a journey into the unknown, a chance to discover something new, something that will change our understanding of the planet. And the possibilities are endless. What new species are lurking in the depths? What new ecosystems are waiting to be discovered? What secrets does the deep sea hold about the origins of life, the evolution of species, and the future of our planet? These are questions that drive scientists to explore the deep sea, to push the boundaries of human knowledge, and to unlock the mysteries of the abyss. But the barriers to exploration are not just technological. They're also psychological, cultural, and even economic. Why does space exploration capture the public imagination, while ocean exploration often gets overlooked? Why do we tend to look up, rather than down, for answers to our biggest questions? These are the questions we'll explore next, as we delve into the barriers beyond technology and uncover the strange human tendency to ignore the vast, unexplored world beneath our feet. Chapter 5. The Unexplored Majority. Examining the staggering scale of what remains unknown, from unmapped underwater mountain ranges to unexplored ocean trenches, discussing how every deep-sea expedition reveals new ecosystems and species, and contemplating the possibility that entire categories of life remain undiscovered. Imagine standing on the edge of the Grand Canyon. You can see for miles, yet you know that even with your eyes, much remains hidden in shadow, in the details too small to perceive from such a distance. Now, amplify that feeling 1,000-fold. That's the scale of our ignorance when it comes to the deep sea. We speak of mapping the Earth, but the maps we have of our ocean floors are, in many places, less detailed than our maps of Mars or Venus. We possess startlingly coarse representations of vast underwater mountain ranges, canyons dwarfing the Grand Canyon itself, and plains so immense they could swallow continents whole. Think about this. Our understanding of the Himalayas is more complete than our grasp of the mid-ocean ridge, a continuous mountain chain snaking for over 40,000 miles beneath the waves. This ridge, born of volcanic fire, is the birthplace of new oceanic crust, the very engine of plate tectonics. Yet, vast stretches of it remain unexamined, silent, and alien. And then there are the trenches. The Mariana Trench, the deepest scar on our planet, plunges nearly 7 miles down. It's a place where the pressure is over 1,000 times greater than at sea level, a realm of perpetual night. We've sent probes there, fleeting visits that scratch the surface of understanding. But to truly explore these abyssal plains, to understand the forces that shape them and the life that clings to existence within them, requires a sustained and dedicated effort that simply hasn't materialized. Why this neglect? Perhaps it's the tyranny of distance, the sheer inaccessibility of these places. Or maybe it's a failure of imagination, a lack of compelling narratives that can capture the public's attention. Whatever the reason, the fact remains. The deep sea is the largest unexplored environment on Earth. Every time we send a submersible into these depths, we encounter the unexpected. We find new species, bizarre adaptations, and ecosystems that defy our preconceived notions. It's like stumbling upon a hidden valley in the Amazon, teeming with creatures never before seen by human eyes. But instead of a valley, it's an ocean. Instead of a few new species, it's potentially entire branches of the tree of life. Consider the hydrothermal vents. These are underwater geysers that spew superheated, mineral-rich water into the frigid depths. For decades, we believed that sunlight was the ultimate source of energy for all life on Earth. Then, in the late 1970s, scientists discovered these vents, teeming with life that thrived not on sunlight, but on chemosynthesis, a process that converts chemicals into energy. Tube worms, giant clams, and bizarre shrimp clustered around these vents, forming oases of life in the otherwise barren abyss. It was a revelation, a glimpse into an entirely different way of living. And it opened our eyes to the possibility that similar ecosystems might exist elsewhere in the deep sea, perhaps even in places we haven't even begun to look. Think about the scale of this. We've explored less than 5% of the ocean floor. That means that over 95% remains a mystery. Within that unexplored majority, there could be countless hydrothermal vents, undiscovered canyons, and hidden mountain ranges. Each of these could harbour unique ecosystems, teeming with life forms unlike anything we've ever seen. What if there are entire phyla of animals, fundamental body plans so different from anything we know, that remain hidden in the deep? What if there are undiscovered forms of energy, novel biochemical processes, or even entirely new states of matter waiting to be discovered? It sounds like science fiction, doesn't it? But the history of science is filled with examples of discoveries that were once considered impossible. The idea that life could exist without sunlight, for example, was once dismissed as fantasy. Now, it's a cornerstone of our understanding of deep-sea ecology. So, what are the chances that we've already found everything there is to find? What are the odds that we've exhausted the possibilities of life on Earth? The answer, based on what we already know about the deep sea, is almost certainly no. Every expedition into the abyss is a gamble, a roll of the dice. But the potential payoff is enormous. The discovery of a single new species can revolutionize our understanding of biology. The discovery of a new ecosystem can challenge our assumptions about how life works. And the discovery of a new form of energy could transform our world. But it's not just about the potential for scientific breakthroughs. It's also about the sheer wonder of discovery. There's something profoundly moving about the idea that there are still places on our planet that remain untouched by human hands. Places where the natural world continues to unfold in its own mysterious way. These unexplored depths are a reminder of our own limitations, of the vastness of the universe, and of the endless possibilities that lie beyond our current understanding. They are a source of hope, a testament to the resilience of life, and a challenge to our curiosity. The deep sea is not just a place of darkness and pressure. It's a place of potential, a frontier of discovery, and a mirror reflecting our own ignorance. It's a place that demands our attention, our respect, and our unwavering commitment to exploration. Consider the deep-sea anglerfish, a creature seemingly plucked from a nightmare. It lures its prey with a bioluminescent lure, a glowing beacon in the darkness. But what if that anglerfish represents just the tip of the iceberg? What if there are other creatures down there, even more bizarre, even more alien, that we haven't even begun to imagine? Think about the scale of the problem. We have better maps of the surface of Mars than we do of our own ocean floor. We spend billions of dollars exploring space, searching for life on other planets. But what about the life that's right here, on our own planet, hidden beneath the waves? It's a question of priorities, of course. Space exploration is exciting, glamorous, and politically appealing. But deep-sea exploration is just as important, just as challenging, and potentially just as rewarding. The deep sea is not just a scientific curiosity, it's also a vital part of our planet's ecosystem. It plays a crucial role in regulating the climate, in cycling nutrients, and in supporting the global food web. We know that the deep ocean acts as a massive carbon sink, absorbing vast amounts of carbon dioxide from the atmosphere. This helps to mitigate the effects of climate change, but we don't fully understand how this process works or how it might be affected by human activities. We also know that the deep sea is home to a vast array of microorganisms, bacteria, and archaea that play a crucial role in nutrient cycling. These organisms break down organic matter, releasing nutrients that are essential for life in the surface waters. But we don't fully understand the diversity of these organisms or their role in the global ecosystem. And then there's the question of deep-sea mining. As we deplete resources on land, we're increasingly turning our attention to the deep sea, where vast deposits of minerals and metals lie waiting to be exploited. But deep-sea mining could have devastating consequences for the environment. It could destroy fragile ecosystems, release toxic chemicals into the water, and disrupt the delicate balance of the deep-sea food web. We need to proceed with caution to carefully assess the potential risks and benefits of deep-sea mining before we start tearing up the ocean floor. We need to invest in research to better understand the deep-sea environment and to develop sustainable methods of resource extraction. The deep sea is not just a resource to be exploited. It's a treasure to be protected. It's a place of wonder, a place of mystery, and a place that holds the key to understanding our planet. So, what does the future hold for deep-sea exploration? Will we ever fully explore the abyss? Will we ever unlock all of its secrets? It's impossible to say for sure. But one thing is certain. The deep sea will continue to challenge us, to inspire us, and to remind us of the vastness of the unknown. We may never reach a point where we can say that we have fully explored the deep sea, but that's okay. The journey is just as important as the destination. The act of exploration, the pursuit of knowledge, and the sense of wonder that comes with discovery are all valuable in themselves. And who knows what we might find along the way? Perhaps we'll discover new forms of life, new sources of energy, or new insights into the workings of our planet. Perhaps we'll even discover something that changes our understanding of what it means to be human. The deep sea is a frontier, a challenge, and an opportunity. It's a place where anything is possible, and it's waiting for us to explore it. Imagine a world where we have the technology to explore the deep sea as easily as we explore space. Imagine a world where we can send fleets of autonomous robots to map the ocean floor, to study deep-sea ecosystems, and to search for new forms of life. It's not just a pipe dream. Advances in robotics, artificial intelligence, and materials science are making it increasingly possible to explore the deep sea in a cost-effective and sustainable way. We're developing new types of submersibles that can withstand the crushing pressures of the deep sea, new sensors that can detect the faintest traces of life, and new algorithms that can analyze vast amounts of data. We're also learning how to work with the unique challenges of the deep sea environment, such as the lack of light, the extreme temperatures, and the corrosive effects of seawater. The future of deep sea exploration is bright. We're on the verge of a new era of discovery, an era that will transform our understanding of our planet and our place in the universe. But we need to invest in research to train the next generation of deep-sea explorers and to foster a culture of innovation. We need to make deep-sea exploration a priority not just for scientists, but for everyone. The deep sea is not just a place for experts, it's a place for all of us. It's a place that inspires awe, that sparks curiosity, and that reminds us of the importance of exploration. So, let's dive in. Let's explore the deep sea together. Let's unlock its secrets, protect its treasures, and share its wonders with the world. The possibilities are endless. The future is waiting. The deep sea is calling. Will we answer? What we've seen so far is just a glimpse, a tantalizing taste of what lies hidden. But the barriers to exploring these depths aren't just technological or financial. They run deeper, into the very core of our psychology. And that's what we'll confront next, when we ask, why do we look up instead of down? Chapter 6. Barriers Beyond Technology. Exploring the psychological, cultural, and economic factors that keep us from exploring the deep sea. Examining why space exploration captures public imagination while ocean exploration doesn't. And discussing the strange human tendency to look up rather than down for answers to our biggest questions. It's easy to point to technological limitations as the reason why the deep sea remains so unexplored. After all, building submarines that can withstand crushing pressure isn't exactly a walk in the park. But what if I told you the barriers run deeper than just engineering? What if the biggest obstacle isn't what we build, but what we simply don't do? Think about it. We live on a planet covered in water, yet our collective gaze is almost always directed skyward. Why is that? Part of it, I suspect, comes down to simple visibility. On a clear night, the stars are there, shimmering, beckoning. You can see them with your naked eye. You can point them out to your children. You can feel a connection, however distant, to something vast and unknowable. The deep sea, you need specialized equipment just to catch a glimpse. And even then, what you see is often fleeting, a momentary flash of bioluminescence in an endless black void. It's not exactly the kind of spectacle that inspires awe in the casual observer, but there's more to it than that. Space exploration has, for decades, been carefully cultivated as a grand, aspirational endeavor. It's about pushing boundaries, about discovering new worlds, about the potential for colonizing other planets. It's a narrative of progress, of human ingenuity triumphing over the impossible. Ocean exploration? It often gets framed as a niche scientific pursuit. Important, yes, but hardly the stuff of dreams. When was the last time you saw a child dressed up as a deep-sea explorer for Halloween? Or a major Hollywood blockbuster about the thrill of discovering a new species of anglerfish? Consider the funding. Space exploration consistently receives billions of dollars in government and private investment. Ocean exploration? A fraction of that. We're willing to spend unimaginable sums to search for life on Mars, but often struggle to justify the cost of mapping the ocean floor right here on Earth. Why this disparity? Perhaps it's because space represents an escape, a chance to start over, to leave behind the problems of our own planet. The ocean, on the other hand, is a constant reminder of those problems. Pollution, overfishing, climate change. It's a mirror reflecting back our own failings. And let's be honest, the deep sea can be a little unsettling. It's dark, it's cold, it's full of creatures that look like they crawled straight out of a nightmare. Space, for all its dangers, at least offers the illusion of emptiness, of a blank slate. The deep sea is teeming with life, but life that is so alien, so different from our own, that it can be difficult to comprehend. There's a psychological barrier at play here. We are, by and large, terrestrial creatures. We evolved on land, we breathe air, we thrive in sunlight. The ocean is, in many ways, a foreign world. It operates according to different rules, it demands different adaptations. It's a place where we are fundamentally out of our element. This disconnect extends to our cultural narratives. Think about the stories we tell ourselves about the sea. They're often tales of danger, of shipwrecks, of monstrous creatures lurking in the depths. The ocean is a force to be reckoned with, a place of peril and uncertainty. Space, on the other hand, is often portrayed as a realm of limitless opportunity, a place where anything is possible, a place where humanity can reach for the stars. It's a powerful narrative, and one that has captured the imagination of generations. But what if we shifted our perspective? What if we started to see the deep sea not as a terrifying abyss, but as a treasure trove of scientific discovery? What if we recognized that understanding the ocean is not just a matter of scientific curiosity, but a matter of survival? Because here's the thing. The deep sea is not separate from us. It's not a distant world that has no bearing on our lives. It's intimately connected to everything that happens on this planet. It regulates our climate, it produces the oxygen we breathe, it supports a vast web of life that ultimately sustains us all. Ignoring the deep sea is like ignoring a vital organ in our own body. We may not see it, we may not fully understand how it works, but we depend on it for our very existence. So, how do we overcome these barriers? How do we shift our collective gaze from the stars to the depths? It starts with education, with inspiring the next generation of ocean explorers, with fostering a sense of wonder and curiosity about the underwater world. It also requires a change in our cultural narratives. We need to tell stories that celebrate the beauty and importance of the ocean. Stories that highlight the incredible diversity of life that thrives in the deep sea. Stories that remind us that we are all connected to this vast and mysterious realm. And, of course, it requires investment. We need to dedicate more resources to ocean exploration. We need to develop new technologies that allow us to explore the deep sea safely and efficiently. We need to support the scientists and researchers who are working tirelessly to unlock the secrets of the underwater world. It won't be easy. Overcoming these psychological, cultural, and economic barriers will require a concerted effort. But the potential rewards are enormous. By exploring the deep sea, we can gain a deeper understanding of our planet. We can discover new medicines and technologies, and we can ultimately ensure the survival of our species. But perhaps the most profound reward will be a shift in our perspective. A realization that the greatest discoveries are not always to be found in the most distant corners of the universe, but sometimes in the hidden depths of our own planet. A renewed sense of wonder and humility in the face of the unknown. And what about the strange human tendency to look up rather than down? Is it simply ingrained in our nature? Are we destined to always seek answers in the stars while ignoring the mysteries that lie beneath our feet? I don't think so. I believe that we are capable of both. We can explore the cosmos and the deep sea. We can reach for the stars and plumb the depths. We can embrace both the known and the unknown. But it requires a conscious choice, a decision to prioritize exploration, to value knowledge, to embrace the mystery. It requires us to overcome our own biases and limitations, to see the world with fresh eyes, and maybe, just maybe, to look down for a change. Because what we find there might just surprise us. It might just change everything. The challenges are immense. The pressure, the darkness, the sheer vastness of the unexplored. But the potential rewards, the secrets waiting to be uncovered, are even greater. And as we begin to chip away at these barriers, as we begin to truly explore the deep, we are forced to confront a fundamental question. How does this hidden world influence our own? What role does it play in the delicate balance of life on Earth? Because next, we uncover the deep's hidden influence and the secrets it holds to our planet's very survival. I hope you're as amazed by this as I am. If you want to stay updated on more content like this, make sure to subscribe and join our community of curious minds. Trust me, what's coming next will challenge everything you thought you knew. Chapter 7. The Deep's Hidden Influence. Revealing how the unexplored deep sea affects every aspect of life on Earth, from climate regulation to oxygen production, discussing deep ocean currents, the carbon cycle, and how creatures we've never seen play crucial roles in maintaining the planet's habitability. The deep sea. It's a world apart, seemingly disconnected from our daily lives. We might think of it as a vast empty space, a place where strange creatures lurk far beyond our reach. But the truth is, this hidden realm exerts a profound influence on everything, even the air we breathe. Think about it. Where does the oxygen we depend on come from? We often picture lush forests, and they certainly play a vital role. But the ocean, and specifically the deep ocean, is a far more significant player in the Earth's oxygen cycle than most of us realize. Microscopic organisms, phytoplankton, drift in the sunlit surface waters, performing photosynthesis and releasing oxygen as a byproduct. When they die, many sink to the deep, carrying with them the carbon they've absorbed. This process, known as the biological pump, is crucial for regulating the Earth's climate. The deep ocean acts as a massive carbon sink, storing vast amounts of carbon dioxide that would otherwise be released into the atmosphere and contribute to global warming. In fact, the deep sea holds more carbon than all the plants and soil on land combined. It's a staggering thought, isn't it? But how does this carbon stay locked away in the deep? And what role do the strange creatures of the abyss play in this process? The answer lies in the intricate web of life that thrives in the most unlikely of places. Creatures we've barely begun to understand. Consider the humble sea cucumber. These bottom-dwelling organisms may not look like much, but they are voracious consumers of organic matter that drifts down from the surface. They essentially vacuum the seafloor, ingesting sediment and extracting the nutrients it contains. In doing so, they help to break down and recycle organic matter, preventing it from accumulating on the seafloor and releasing carbon back into the water column. Then there are the deep-sea worms, the crustaceans, the bizarre fish with their bioluminescent lures. Each plays a part in this complex ecosystem, contributing to the cycling of nutrients and the sequestration of carbon. It's a delicate balance, and we're only just beginning to understand how it all works. But the deep sea's influence extends far beyond the carbon cycle. It also plays a critical role in regulating ocean currents, which in turn influence global climate patterns. Imagine the ocean as a giant conveyor belt, constantly circulating water around the globe. This conveyor belt is driven by differences in temperature and salinity. Cold, salty water is denser than warm, fresh water, so it sinks to the bottom of the ocean. This sinking water creates deep ocean currents that flow slowly but steadily around the world, transporting heat, nutrients, and carbon. These deep ocean currents are vital for distributing heat from the equator towards the poles, moderating temperatures, and influencing weather patterns across the globe. Without these currents, the Earth's climate would be drastically different, with much greater temperature extremes and more frequent and intense storms. The formation of these deep ocean currents is particularly important in the North Atlantic, where cold, salty water sinks to the bottom of the ocean, driving the Gulf Stream. The Gulf Stream is a warm, powerful current that flows along the eastern coast of North America and then across the Atlantic towards Europe, bringing mild temperatures to the British Isles and Scandinavia. Without the Gulf Stream, these regions would be much colder and less habitable. But what happens if the formation of deep ocean currents is disrupted? What if the water in the North Atlantic becomes less salty due to melting ice or increased rainfall? This could slow down or even shut down the Gulf Stream, leading to significant changes in climate patterns across the Northern Hemisphere. Scientists are increasingly concerned about the potential for climate change to disrupt deep ocean currents. As the planet warms, ice sheets and glaciers are melting at an alarming rate, adding fresh water to the ocean and reducing its salinity. This could weaken the formation of deep ocean currents and potentially trigger a cascade of climate impacts. The deep sea is also a vast reservoir of nutrients, which are essential for the growth of phytoplankton and other marine organisms. These nutrients are constantly being recycled between the surface and the deep, ensuring that the ocean remains a productive ecosystem. Upwelling is a process that brings nutrient-rich water from the deep to the surface, fueling the growth of phytoplankton and supporting entire food webs. Upwelling occurs in certain coastal regions where winds and currents push surface water away from the shore, allowing deeper water to rise to the surface. These upwelling zones are some of the most productive ecosystems on Earth, supporting thriving populations of fish, seabirds, and marine mammals. They are also important fishing grounds, providing food and livelihoods for millions of people around the world. But upwelling is not the only way that nutrients are recycled in the ocean. Deep-sea organisms also play a crucial role in this process. As they feed and excrete waste, they release nutrients back into the water column, making them available to other organisms. Even the carcasses of whales that sink to the bottom of the ocean can provide a bonanza of nutrients for deep-sea communities. These whale falls support a diverse array of scavengers and decomposers, creating oases of life in the otherwise barren deep. It's incredible to think that creatures we've never even seen can have such a profound impact on our planet. They are the unsung heroes of the deep, working tirelessly to maintain the Earth's habitability. We are dependent on the deep sea in ways we are only beginning to understand. Its influence extends far beyond the coastline, affecting our climate, our weather, and even the air we breathe. It's a hidden world, but it's a world that we cannot afford to ignore. And the more we learn about the deep sea, the more we realize how much more there is to discover. Every expedition reveals new species, new ecosystems, and new insights into the workings of our planet. It's a frontier of scientific exploration, and it holds the key to understanding some of the most pressing challenges facing humanity. Consider the potential for discovering new medicines in the deep sea. Many deep-sea organisms have evolved unique adaptations to survive in extreme environments, and these adaptations could hold the key to developing new drugs and therapies. Scientists have already discovered a number of promising compounds from deep-sea organisms, including anti-cancer agents, antibiotics, and anti-inflammatory drugs. The potential for further discoveries is enormous, but it requires us to invest in deep-sea exploration and research. The deep sea also holds valuable mineral resources, including rare earth elements that are used in electronics and renewable energy technologies. As demand for these resources grows, there is increasing interest in deep-sea mining. But deep-sea mining could have devastating impacts on deep-sea ecosystems, which are already under stress from climate change and pollution. We need to carefully weigh the potential benefits of deep-sea mining against the potential risks to the environment. It's a complex equation, and it requires us to make informed decisions based on the best available science. We need to explore the deep sea responsibly, ensuring that we protect its biodiversity and its vital role in maintaining the health of our planet. The deep sea is not just a remote and mysterious place. It's an integral part of our world, and it's essential that we understand its influence and protect its future. Our fate is intertwined with the fate of the deep, and we must act accordingly. But as we've seen, even the most technologically advanced research can only scratch the surface of understanding the deep sea. We've explored the technological barriers, the crushing pressure, and the perpetual darkness. But what if the biggest barriers are not physical, but psychological? What if our own minds are preventing us from truly grasping the full scope of the deep's influence? This is where our journey takes an unexpected turn, because next, we'll delve into the strange human tendency to look up rather than down for answers to our biggest questions. Chapter 8: Forever Unknown. Contemplating whether the deep sea will ever be fully explored. Discussing the philosophical implications of permanent mystery in our modern world, and finding peace in the idea that some frontiers may remain forever beyond our reach. preserving the wonder and humility that mystery brings to human existence. Will we ever truly know the deep sea? It's a question that haunts scientists and explorers alike. After all, we've charted the surface of Mars with greater precision than the bottom of our own oceans. We've peered into the hearts of distant galaxies, yet entire ecosystems thrive just miles beneath the waves, unseen and largely untouched by human eyes. Is complete exploration even possible? Consider the sheer scale of the challenge. The deep sea isn't a single, uniform environment. It's a tapestry of vastly different habitats, each with its own unique conditions and inhabitants. From the abyssal plains to the towering hydrothermal vents, from the sunless trenches to the underwater mountain ranges, the deep sea is a world of endless variety. And it's constantly changing. Ocean currents shift, volcanic activity ebbs and flows, and the very seabed itself is in a state of perpetual transformation. To fully explore the deep sea would require a constant, unwavering presence, a level of observation that is simply beyond our current capabilities. But perhaps the greatest barrier to complete exploration is the very nature of discovery itself. Every expedition to the deep sea reveals something new, something unexpected, something that challenges our understanding of life on Earth. It's a process of constant revision, of continually updating our maps and rewriting our textbooks. So, even if we were to somehow map every inch of the seabed, identify every species, and analyze every chemical process, would we truly have explored the deep sea? Or would we simply have created a snapshot in time, a fleeting glimpse of a world that is forever evolving? Perhaps the answer lies in accepting the inherent limitations of our knowledge. Perhaps the deep sea is destined to remain forever partially unknown, a realm of perpetual mystery. And maybe, just maybe, that's not such a bad thing. In a world increasingly defined by data and analysis, by the relentless pursuit of certainty, there's something profoundly comforting in the idea of a place that resists our attempt to fully comprehend it. A place where the unknown still reigns supreme. This isn't to say that we should abandon our efforts to explore the deep sea. On the contrary, we should continue to push the boundaries of technology, to develop new tools and techniques that allow us to peer deeper and further into the abyss. But we should also approach this exploration with a sense of humility, with an awareness of the limits of our knowledge, and with a deep respect for the mystery that lies at the heart of the deep sea. Think about it. For centuries, humans have looked to the stars for answers to the biggest questions. Where do we come from? Are we alone? What is our place in the universe? And while the exploration of space has undoubtedly yielded incredible discoveries, it has also revealed the vastness of the cosmos, the sheer scale of our ignorance. The more we learn about the universe, the more we realize how much we don't know. The deep sea offers a different kind of mystery, a mystery that is closer to home, a mystery that is intertwined with the very fabric of our planet. It's a reminder that there are still frontiers to be explored, not in the distant reaches of space, but right here on Earth. And perhaps, in grappling with the mysteries of the deep sea, we can gain a deeper understanding of ourselves, of our place in the natural world, and of the limits and possibilities of human knowledge. Consider the philosophical implications of a permanently mysterious realm. In a world increasingly obsessed with answers, the deep sea offers a refreshing reminder of the importance of questions. It's a place where curiosity can thrive, where imagination can run wild, and where the pursuit of knowledge is an end in itself. The deep sea challenges our assumptions about what is possible. It forces us to confront the limits of our understanding. It reminds us that there are forces at work in the world that are far beyond our control. And in doing so, it can help us to cultivate a sense of humility, a sense of awe, and a deep appreciation for the complexity and fragility of life on Earth. Imagine a future where the deep sea remains largely unexplored, a vast and mysterious realm that continues to inspire wonder and curiosity. A place where new species are constantly being discovered, where the boundaries of life are constantly being redefined, and where the potential for new discoveries is limitless. In such a future, the deep sea would serve as a constant reminder of the importance of preserving the unknown, of protecting the wild places of our planet, and of fostering a sense of respect for the natural world. It will be a place where we can reconnect with our sense of wonder, where we can escape the noise and distractions of modern life and where we can find solace in the face of the unknown. But finding peace in the unknown isn't always easy. It requires a shift in perspective, a willingness to embrace uncertainty, and an acceptance of the limits of our knowledge. We are, by nature, creatures who seek answers. We want to understand the world around us, to make sense of the chaos, and to predict the future. But the deep sea resists our attempts to fully comprehend it. It challenges our assumptions about how the world works. It forces us to confront the fact that there are some things that we may never know, and that can be unsettling. It can be frustrating. It can even be frightening. But it can also be liberating. Because in accepting the unknown, we free ourselves from the burden of certainty. We open ourselves up to new possibilities. We allow ourselves to be surprised and delighted by the unexpected. We can find peace in the idea that some frontiers may remain forever beyond our reach. It's a humbling thought, but it's also a profoundly comforting one. It reminds us that we are not the masters of the universe, that there are forces at work in the world that are far greater than ourselves. And it encourages us to approach the world with a sense of humility, with a sense of awe, and with a deep respect for the mystery that lies at the heart of existence. Think about the great explorers of the past: Magellan, Columbus, Armstrong. They all ventured into the unknown, driven by a thirst for discovery, a desire to push the boundaries of human knowledge. But they also faced immense challenges, setbacks, and uncertainties. They sailed into uncharted waters, navigated through treacherous terrain, and confronted dangers that were beyond their comprehension. And yet, they persevered. They pushed forward, driven by a belief in the importance of exploration, a conviction that the rewards of discovery were worth the risks. We can learn from their example. We can embrace the challenges of deep-sea exploration, not with a sense of arrogance or entitlement, but with a sense of humility and respect. We can acknowledge the limits of our knowledge, but we can also celebrate the power of human curiosity, the ingenuity of human innovation, and the unwavering human spirit that drives us to explore the unknown. Ultimately, the question of whether the deep sea will ever be fully explored is less important than the journey itself. It's about the process of discovery, the thrill of the unknown, and the constant pursuit of knowledge that defines our species. It's about preserving the wonder and humility that mystery brings to human existence. It's about fostering a sense of curiosity and a love of learning that will inspire future generations to explore the depths of our planet and the farthest reaches of the universe. The deep sea is a gift, a treasure trove of scientific knowledge, a source of endless inspiration, and a reminder of the importance of preserving the unknown. Let us cherish it, protect it, and continue to explore it with a sense of wonder and respect. But what if the very act of exploration changes the thing we seek to understand? What if our presence in the deep sea, even with the most advanced technology, leaves an indelible mark on this pristine environment? That's the question we'll grapple with next as we delve into the ethical dilemmas of deep-sea exploration. Are we explorers, or are we simply intruders?